if it is vector differentiation, let us start with the definition. Scalar point function. Yesterday in the point itself I gave phi of x comma y comma z. We generally denote the scalar function like phi of x y z or any other function also. But theoretically I have given you as phi of x comma y comma z. In general you can denote that as f of x comma y comma z or g of x comma y comma z, anything. We are basically discussing three-dimensional functions. In intermediate already you discussed two-dimensional. Now you are discussing three-dimensional. Suppose I give you the difference between a scalar and a vector. Now suppose if I take a paper, if I leave this paper from certain height, will it go the way I tell?
No.
Will it go, suppose if I draw, I will tell the paper go this way, will it go? Implies what this particular paper has got magnitude but no direction. Implies this paper is called simply a scalar. So only you can see in the definition which I gave yesterday that scalar point function has got only magnitude but no direction. So magnitude means what? It can be either length. Suppose if I take simple thread will have length, not like volume or area. Similarly, this paper has got area but no length or volume. I folded this paper like this. Now it has got volume because it is in sphere shape. So, but still it is a scalar only because if I drop this from certain height, it will not go the direction which I tell. So, scalar function means it will have only magnitude but no direction. That is first definition. Next, I gave you the definition of vector point function. In general, vector point function we denote as f. It is also in terms of three variables because we are in three-dimensional space. So f of x y z equal to f1i plus f2j plus f3k. This is how we denote a vector. Can you let me know what are I, j, k means? Can anyone tell what is I?
Direction.
I is what?
Upward direction.
I is unit vector along
X-axis.
Very good. J is
Vector along y-axis.
excellent. K is
Unit vector along x-axis.
suppose if I consider this point as origin, if I consider this as origin, this is x-axis, this is y-axis, and this is z-axis. So one unit vector, if I consider I move 2 steps. So what is the total length I traveled along x-axis? 2i. Because along x-axis I took 2 steps. One step is denoted as I. 2 steps is denoted with 2i. Along y-axis again I moved 3 steps. What is unit vector along the y-axis? Then when I moved 3 steps it is along z-axis I moved 4 steps. Then it is so this is called because I got a direction there. I am moving in a particular direction. It has got direction as well as it has got magnitude. It will have a value. So then it is called vector. Vector point function is nothing but a function which has got both magnitude and direction. That is what second definition I gave. Next, the third definition is vector differential operator. Vector differential operator we denote with del and is denoted by or it is written as I dou by dou x plus j dou by dou y plus k dou by dou z. This is called vector differential operator. What do you mean by derivative? Can you tell? Can anyone tell what do you mean by derivative? I already told. Okay, last, what is velocity? Rate of change of
Speed.
with respect to
Time.
what is changing with respect to what? Displacement is changing with respect to implies what? There will be a change in one quantity with respect to. Suppose if I write velocity rules we are following? Now along x-axis the change is denoted by dou by. Along y-axis change is. Along z-axis the change is. Now total change nothing but del. I dou by dou x plus j dou by dou y plus k dou by. And this only we call it as vector differential operator. What it is called? Vector differential operator. That is what the third point. Hope you understand. Now let me know what is fourth point. Gradient. Gradient means suppose I tell you an example. Suppose I just took an example of a paper. It is not moving. I want this paper to move the direction which I want. నేను అన్న డైరెక్షన్ లో ఈ పేపర్ వెళ్ళాలంటే ఏం చేయాలి? నేను దీనిలో థ్రెడ్ కడతాను. ఇది ఇక్కడ నుంచి పడేస్తే నేను చెప్పిన డైరెక్షన్ లో వెళ్ళాలా? ఇట్ ఇస్ కాల్డ్ స్కేలర్. ఇప్పుడు నేను దీన్ని వెక్టర్ చేస్తాను. వెక్టర్ ఎలా చేస్తా? ఐ టై ఎ థ్రెడ్ టు దిస్. ఇట్ విల్ బికమ్ ఎ కైట్. Before tying thread, will it go the direction which we say? No. After tying the thread, it will go the direction which I make it. Then దాని ఏ డైరెక్షన్ లో పంపిస్తే ఆ డైరెక్షన్ లోకి వెళ్తుంది. Now it will become a vector. So now suppose if I consider a gradient, a scalar point function phi, and apply vector differential operator to that, it will become a vector. I dou phi by dou x plus j dou phi by dou y plus k dou phi by dou z. I repeat again. Before tying thread, it is simply a scalar. Before tying a thread, it is simply a scalar. Phi is a scalar point function. Now I want to make it phi. Correct ga నేను ఏ డైరెక్షన్ లో చెప్తే ఆ డైరెక్షన్ లో వెళ్ళాలి కాబట్టి now I will tie a thread. If I tie a thread, this will behave as a vector. That vector only is nothing but this gradient. We call it as gradient del phi. Gradient and simply we denote as grad phi. Del phi I dou phi by dou x plus j dou phi by dou y plus k dou phi by dou z. It is called a vector or it is called normal vector. Whatever the thread we have tried, it behaves as a vector which is drawn outward to the surface. Maybe intermediate you might have heard normal vector drawn outward to the surface. Have you heard of that?
Yes, ma'am.
A normal vector drawn outward to the surface. Okay, leave it. At least you understand the example. So kite అయిపోయిన తర్వాత kite ఎగరాలంటే ఒక వెక్టర్ కావాలి కాబట్టి దానికి ఒక డైరెక్షన్ చూపించాలి కాబట్టి ఆ డైరెక్షన్ కోసం we are tying a ఆ thread tie చేయడం వల్ల it will become as a vector which is showing the direction to the surface. That is only we call as gradient. Hope you understand. What is the next definition? Normal vector. This is nothing but the normal vector. In general, normal vector to any surface is nothing but del phi. Just now I wrote normal vector for any surface phi is given by I dou phi by dou x plus j dou phi by dou y plus k dou phi by dou z. I'll give you some more examples later. What is the next definition? What it is? So if n bar is normal vector, unit normal vector is denoted by n cap and it is given by n bar by mod n. Repeat again. How do we denote unit normal vector with? N bar is normal vector, n cap is unit normal vector given by n bar by implies from where we have tied the thread. And ఆ kite కి ఎక్కడి నుంచి అయితే thread tie చేసామో మనం ఎక్కడ పట్టుకున్నామో ఆ particular length is its magnitude. Nothing but mod n bar. That what is the next one? Directional